ตอนนี้จะเป็นการบรรยายจากทาง MSC Software นะคะเกี่ยวกับแนวโน้มของรถยนต์ไฟฟ้าและเทคโนโลยีด้าน Simulation นะคะในชื่อหัวข้อ Electric Vehicle Trend and Simulation Technology นะคะวันนี้ได้รับเกียรติการบรรยายจาก Mr. MD Kemarol Ibrahim นะคะ Over to you Kemarol.
So thank you very much everyone. As introduced, my name is Kemarol. I oversee the technical engagement for MSC Software in our ASEAN region. So today, I would like to talk about this electric vehicle and its trend and simulation technology that MSC has. So, of course, today I will talk about the design solution as well from the perspective of simulation technology. And I would like to focus a little bit on the acoustic issues and the solution. So I believe everybody knows that globally, electric vehicle market is expected to grow 5 times by 2030. This is in the view of a replacement to the existing internal combustion engine market. And according to the Boston Consulting Group, EV vehicle is expected to grab more than 50% of the traditional vehicle market worldwide. So battery electric vehicle alone is looking at launching more than 400 models among all the manufacturers worldwide. This graph is actually showing the EV investment worldwide and where the investment flows. What we can see from here, we see the large investment goes to China, either originated from Germany, Japan, Sweden, France, or China themselves. Nevertheless, globally, we are looking at most of the developed countries with electric vehicle OEM will continue to invest in electric vehicle itself. So it is a trend that is globally moved the automotive manufacturer or automakers worldwide into a certain direction, which is fulfilling the SDG requirement, Sustainable Development Goals requirement. So in global economy, many companies are suffering due to the shocking event of COVID-19 especially. Many may reserve to invest. They don't want to invest. However, we see that investment in EV market globally is growing, especially by the end user themselves who think that EV or electric vehicle definitely can defeat the growing oil cost worldwide. So the electric vehicle registration in France, for example, has been making its position in the pie chart aggressively, as you can see from the graph here. This news shows how serious OEM in the global market are investing in this strategic investment, which is electric vehicle. There has been losses, for example, by Daimler when they faced the diesel-related issue and also the airbag issue previously. So how they want to compensate this and at the same time invest into electric vehicle is that they are looking at the cutting costs by laying off people worldwide and take that fund to fund the electric vehicle development. So same goes with Audi. They're looking at laying off around 9,500 employees within 4 years and divert the investment into the electric vehicle program. Now, we look at the ASEAN-related electric vehicle investment news. In ASEAN, the push for electric vehicle, especially in Thailand, has been put on the major oil companies. So, for example, I think many of us read that Thai oil major company like PTT has launched $60 billion push into electric vehicle and also the green energy. So we see that the trend from developed country is coming from automotive OEM But in emerging countries or developing countries like ASEAN, it's coming from non-automotive mainly. So both governments and industry are working hand in hand to push for electric vehicle development. And I believe Thailand especially has the most advantage in this segment due to the complete automotive supply chain as a result of 30 years collaboration with automotive makers, especially with the Japanese. In Malaysia, we see some news related to pushes into electric vehicle, especially in the charging infrastructure, and also the focus on the electric vehicle bike. So electric vehicle doesn't mean the car alone. It can mean the buses, the public transport. In Philippines we have this we'll call it similar to Thailand, we have the tuk-tuk, right? So this is minibuses electric vehicle investment by Philippines. And also in Singapore, the focus is a little bit different. They are funding the startup companies to push for EV adoption in Singapore and also the ASEAN region. So, like I said, Thailand actually has the most advantage in this region to develop the full vehicle of electric vehicle parts and components. But each country in ASEAN is looking at grabbing some of the market. For example, Philippines is looking at the parts manufacturing. Indonesia is looking both at parts and also the battery manufacturing. Malaysia is looking at the infrastructure and also electronic components. So all of us, all the ASEAN government is making a way and taking a steps into the electric vehicle. Let's take a look on the anatomy of an electric vehicle. We know the transition to electric vehicles will not happen as a single step. The adoption of battery electric vehicle today is at stake because of cost reason, but same goes like lack of recharging infrastructure, the range anxiety issues. People are looking whether electric vehicle can let them to travel more than 100 kilometers, more than 200 kilometers away from the origin of the start point. Then intermediate steps are available, but they involve increasing complexity of the coexistence between the internal combustion engine propulsion and also the electrical counterpart. So this dilemma is faced by the whole auto industry and needs to explore multiple paths before it can reach to battery electric vehicles. So that's why we see the mild hybrid vehicle, hybrid vehicle, plug-in hybrid vehicle, and some already step up into the battery electric vehicle themselves. So never as today, the auto industry need to fully leverage the power of simulation and also the measurement in their design and engineering solution. Let's take a look on the anatomy of electric vehicle. So there are few main components such as battery pack, normally developed by OEM, e-powertrain that consists of motor and also the gearboxes, which is developed by both OEM and also tier 1 suppliers. Power electronics mainly developed by tier 1 suppliers, but the control software mainly developed by the OEM. So these are the design for platform approach. So many companies are looking at the one chassis, one platform to make the model varieties of the model. So this is one example of modular electric matrix by the Volkswagen. So they're using the same chassis, the same model of the platform to vary the design and also the model of the car. So the advantage of using the same platform is that they can have push for the mass production and also reduce the cost of the chassis development. because chassis development is one of the most costly development in any automotive company. So not only, I think, not only Volkswagen, there are many other OEMs looking at this modular approach to reduce the cost of electric vehicle development. So putting the battery at the bottom, they call it a scale modular approach to develop various of model in the market and introduce various model in the market. Then we look at the taxonomy of energy storage itself. Of course, we have a battery, the cell, then the combination of the cell become a module, then the combination, the assembly of the module will become a pack. Let's take a look on the design and manufacturing challenges. So first of all, let me directly go into the core contents of the discussion. So one of the main challenge when we talk about the electric vehicle is the all-time issue related to the range anxiety. This topic is the main challenge for many nations to adopt electric vehicle as part of the sustainability roadmap. Engineers are looking at this issue by tackling various subtopics such as the optimization of the powertrain, improving the battery thermal management to increase the efficiency, applying the lighter material to reduce the consumption of the battery and reduce the tire rolling resistance, similarly to reduce the battery consumption. The other key issue related to manufacturing and a quality assurance aspect. For example, modular manufacturing approach might require the rearrangement of supply chain. An extensive lightweight might require manufacturer to think about the joining between dissimilar material, for example, steel with aluminum with the plastics. So digital twins actually open up opportunity to integrate the direct feedback from field into product design as an actionable items. We're also looking at this driver and passenger experience. Okay? So what we can see here, electric vehicle is actually perceived as a luxury car, a car that is full of electronics. So people are expecting that the expectation of the driver towards the quality and experience inside the car is very high. So the demand of a cabin comfort, the cabin noise must be reduced. The car must have more electronic functionality. So these become growing in terms of when they want to purchase the electric vehicle. So finally, when we achieve all these, we need to have a better performance of the car. So for example, performance on acceleration, and this lead to the issue of torque vectoring because of, previously it's based on the combustion engine, but now it's changed to the electric motor. And it's also lead to the NVH, durability issues, and also the safety issue of the battery, especially. Then when it comes to design and engineering, in MSc, we have various solutions that can lead to assist the engineer to solve these issues. If you look at the electric vehicle, whatever the new component installed as compared to conventional internal combustion engine, these are the key components that come together with new challenges. So Hexagon has a solution to address each of segment in electric vehicle. For example, on the lightweighting, we focus on the material. On the battery thermal analysis, we have the solution called Cradle to simulate the thermal flow around the battery. And some also looking at the thermal flow in between the modules, the pack of the battery. And we're also looking at the noise of the generated by the electric powertrain and harshness. We also have a solution that can address the battery safety when the car hitting any bump on the road, because the battery is installed below at the bottom of the car, so it is prone to hit any bumps that the car goes through. So the issue is that the battery consists of lithium ion, and is, if it's leaked, it has a potential to explode, right? Or potential to create a fire inside the battery and create a hazard situation. Now let's put a little focus on the electric vehicle noise. So in this series, we are going to look at the some solution related to acoustic and noise. So obviously, one of the main source of conventional vehicle is the engine, and therefore removing the engine and replace it with electric motor means a huge reduction in of the noise source. But the question is it that simple? So while the answer is actually no, it means a new set of challenges appear to engineer to be solved. So when things become quieter, the smaller marginal or incremental noise become more obvious and sometimes very annoying. So you can imagine that in a quiet place, for example, during the night time, if the water leak in the toilet, even it's very small sound, it will become very annoying to the owner of the house, right? So sometimes it become very irritating. So with the removal of internal combustion engine, there are remaining noise sources that needs to be addressed. It will become dominant, as I explained earlier, and some of it could be the noise from the air condition system, or the noise that coming from the tire, the noise from the wind that goes through the side mirror noise. And this requirement is further amplified with the passenger perceived expectation of the electric vehicle itself as the high-tech technology. And it has to have a better sound quality than the internal combustion engine. One of the main source of noise comes from the electric powertrain itself. However, reducing the total noise also could impact the pedestrian safety, and there are around 20,000 accidents related to the electric vehicle in US alone. I forgot the year, but I think around 2018 or something, that people do not realize that the electric car is coming towards them and just cross the road. So it has to have some sound that can alert the pedestrian about the car is coming. So because of electric vehicle is reduce the noise, the pedestrian does not aware of the incoming vehicle. So authorities are now putting requirement for electric vehicle manufacturer to ensure that EV or electric vehicle to emit a standard noise with the objective to warn the pedestrian of the incoming vehicle. So it could be approached with an artificial sound machine or any type of sensors, make it a sound. So dealing with noise, vehicle and harshness issue, we have two approaches. One is the firefighting approach, and second is the anticipate the problem at the design stage, and perform various type of simulation or various type of testing. But of course, the first one would be difficult because you have to bring the car back and make the changes. But the second one also is not easy because designer has to anticipate the potential problem which is not exist yet. So together with the engineer experience, the problem can be tackled early before the prototyping by means of simulation. So the simulation offers a better solution to the NVH design. Okay, so simulation can help to understand the potential physical phenomena by doing the replication of the actual physical scenario. So for the different electric powertrain technologies, researchers are actually ongoing on finding the best architecture, either by the HEV, by the PHEV, or by the battery electric vehicle itself. But basically, there are two main components inside the electric vehicle. One is the electric motor, and second is the gearbox or the reducer itself. So in order to address the noise that coming from these two components, we can actually look at the process of gear reducer and the transmission noise, and also the noise that coming from the electric motor noise. So let's take a look on the first approach, which is to address the noise that coming from the gear reducer and also the transmission noise. So we have the workflow that can help you to simulate the noise that coming from the gear boxes. In this case, we are using the atoms to simulate the motion and simulate the forces when the gear are contacting to each other. Okay? So the loads are coming from the multi-body dynamic simulation, and the vibration will be transmitted into the surface vibration of the gearbox, and the vibration will be transferred or mapped to the acoustic radiation simulation. So in detail, we have this approach of getting the mesh forces, bearing forces, and translated into the body vibration, and then calculate the acoustic radiation from the surface vibration. So these are the example of gear rattle noise source that coming from the contact forces between the tooth of the gear. So you can see a spike of forces when the gear teeth are contacting to each other. So there is a double-sided contact observed. We can use this model to identify the influential parameters. For example, the pitch or the teeth tip of the gear. And the process is next is to tune the system to achieve the desired rattle-free behavior. MSC as a solution specifically can address the noise that coming from the gear tooth. So we call it this is a toolkit. They call it a gear AT, and from gear AT supports a very accurate description of the flank surfaces, and this was considered as necessary as a gear AT should be able to provide the reliable information about the contact mechanics and its associated design parameters related to the gear itself. So gear AT can help you to produce the results either in a low frequency or high frequency domains. And the concept is very realistic, and it's actually helped not only the expert users, but also the non-expert users to understand how to design the gears and make sure that you are fulfilling the sound or the noise requirement of the vehicle or the gears toolbox. Now I just want to give you this short demo related to the chain simulation from multi-body dynamics to Actron acoustic simulation. So the simulation is done 100% in one environment, which is Adams, by using toolkit called Adams to Actron toolkit. So this is the demo video that shows the simulation in Adams multi-body dynamics environment. First by importing the gear set, and you can see the blue color component is actually a finite element model inside the multi-body dynamics. So we have done this. This technology has been there for many years, But what we will see after this is that the noise or the forces reaction between the bearing and also the gears can be translated or can be mapped into the vibration. And this vibration is actually mapped into the acoustic simulation noise. So we have this plug-in toolkit, we call it Adams to Actron, and you just choose which part that you want to calculate the vibration, and then the toolkit will ask you the range of the simulation time, and you can perform the noise simulation itself. So this is a toolkit that we have inside this Adams to Actron. Right, let me skip a little bit. I just want to show another example of electric motor noise. So we have this solution to address the noise that coming from the electric motor. But before that, we need to understand how electromagnetic forces create noise. The electromagnetic forces primarily coming from the electromagnetic, the forces actually coming from the electromagnetic forces, and then it generate the vibration towards the housing. And then from this housing, we can take the vibration to calculate the acoustic radiation. So one example that we can show here is coming from the Renault on electric vehicle noise simulation. So we mentioned earlier, the challenge in electric vehicle is that the absence of internal combustion expose other noise sources that were previously acceptable, but now become non-acceptable. So the end user of course expect the EV to be very quiet, and therefore during the development, the new electric powertrain Renault has to determine the noise level and reduce the noise before they perform their physical prototyping. Okay? Of course, in terms of generating the electromagnetic forces, Renault is using the third-party software that can generate the electromagnetic forces to perform this type of analysis. So next, there are many other sources of noise and its related phenomena. In electric vehicle that is perceived as a luxury vehicle from many of the buyers, noise is perceived as issues related to the quality, and it must not appear inside the car. There are noise such as the coming from the dash, top door rattle, the noise that coming from the rattling rear deck, roof squeak, hood rattle and squeak, dashboard vent, driver door squeak. So many of these are actually already exist in electric vehicle, in internal combustion engine, but previously it was acceptable because it is masked by the internal combustion engine. But now, because internal combustion engine has been removed, this sound become more obvious to the users, to the drivers. So there are many other ways. There are some of this noise can be related not only from the design issues. It may also link to the manufacturing issues. For example, the squeak and rattle originated from the friction between two different components. For example, the T-pillars might be related to the tight tolerance between the two. So therefore, one of the ways to improve the design is to increase the gap tolerance rather than go back to the design engineering. So MSC, together with our mother company Hexagon, has a solution not only on the design stage, but we also has the solution that can address buzz, squeak, and rattle at the manufacturing level. Okay. So I think that's all. I want to finish my presentation. Thank you very much for listening. I'm open for any questions.